Hey folks, how's it going? This is Mr. Murray coming to you with a little video for Course 2 Honors for Thursday, May 7th, 2020. Okay, so in this do now, what we're going to do is we're going to continue to work on our notion of circumscribed angles and tangents. Okay, so what we have here is we have a quadrilateral, in a sense. We have this circumscribed angle here. All right. And we also have this central angle. And I've gone ahead and I've put this central angle kind of in dotted lines so you can get a sense of what it is. So we can see that we have this measurement here. We have this measurement here. Okay, so given this and given these lengths, etc., and if it helps, I can put this as like degrees. The principles are still the same. I need you to find the measurement of ABC, CDA, these being angles, angle BAD, angle BCD, and then I need you to find the length of AB, the length of AD, and the length of the arc BD. So please take a moment, pause the video. If you need to, go back and take a look at anything we talked about yesterday and yesterday's video. And in fact, I'm going to have that come up right now because that talks about these kinds of things. All right, pause the video, try these, finding these measurements, and then when you're ready, unpause, and you can see what I got. All right, here we go. So the measurement of ABC. So this is a circumscribed angle, and this circumscribed angle is the result of taking two tangent lines and having them intersect outside the circle. Okay, so this is essentially the space between this tangent AB and the tangent AD. Now we know that tangent lines are always perpendicular to the radius that's formed by connecting the center to that point of tangency, that point where the tangent line touches the circle, that one point. So this makes this 90 degrees because we know they're perpendicular. Similarly, this is going to happen with CDA. This is also going to be 90 degrees, or pi over 2 radians. Okay, BAD. Now for BAD and BCD, what we know is that the measurement here plus the measurement of the central angle given has to be 180. Remember what we talked about. If you think about a shape that's formed by, let's say I made these dotted lines solid and I had this quadrilateral, right? Well, the quadrilateral has to have a sum of 180 degrees for its interior angles. But if these are each 90 because they're tangents, then that means that these two have to add up to 180, so that you get 180 plus 90 plus 90 equals 360. Okay, so you get 10x plus 50 equals 180. So 10x equals 130. So x is equal to 13. If x is equal to 13, then BAD is 39 degrees. And then I'll plug in 13 to 7x plus 50, and I get 141 degrees. And we can see that 39 plus 141 is 180. Now the other thing I know is that given that these are tangents, I know that the two side lengths need to be congruent. Sorry, not plus. They need to be congruent. Ooh. For whatever reason, it didn't change over. And why is this? So let's say that I was to form a triangle here. This would be a right triangle, right? Two right triangles. Now, they're right triangles because of this 90-degree angle. Now, their bases are congruent because they're radii of the same circle, and all radii are equal in length. And then the other thing I know is that they share this length in common, right? So by the reflexive property, this is congruent to itself. And so therefore, because this is the hypotenuse of both triangles, these two triangles are hypotenuse leg congruent. And because corresponding parts, these are corresponding parts, and because corresponding parts of congruent triangles are congruent, those two lengths must be equal. So we set them equal to each other. We divide by 4. We're going to go ahead and subtract. It's quadratic, right? We're going to have to use the method of factoring because we've got z's on both sides. We can't just divide out. All right, so what we're going to get is this. Factor out the z minus 9 equals 0. So either z is equal to 0, and if it was, you couldn't divide on both sides here. And z equals 0 doesn't really make sense. You get a length of 0. Or z is equal to 9. That is the answer that makes sense, right? Because you're not going to have a length likely of 0, right? If it's a length of 0, then that would be an issue. That would mean A is literally on top of B, and A is also on top of D. A couldn't be two places at the same time, right? It can't be 0 away from B and 0 away from D if these are two distinct points. So Z is going to be equal to 9, so it makes sense. Okay, so I plug in 9. I do 9 times 9 for 9 squared times 4 for AB, and that's 324. Okay, and then remember, these are lengths, so there's nothing that they necessarily have to add up to as long as they're equal. And now, well, look, this was 4 times 9 times 9, right? Well, look, this is 4 times 9, because it's a 36, times 9, right? 36 is literally 4 times 9. So this is all. So this was 9 times 9 because you were squaring. This is 9 times 9 because you have 36. But we know those are going to have to be equal to each other. So perfect. And then BD, well, because BD is across from the central angle, you know two things. Either BD has the same measurement as BCD, because this is a central angle, or BD is supplementary with 3x, because 3x is supplementary with the central angle, and the central angle is equal there. So BD, because we already know BCD, we know that it's going to be 141 degrees. Okay, but again, you can see it's congruent to the central angle and supplementary with the circumscribed angle. All right, so hopefully you're able to get this right. If so, amazing job. Again, please make sure you're checking the notes for today as we're advancing into the very last thing we're going to talk about with regard to circles. Okay, so make sure you take a look at that and about some important angle relationships. But best of luck. Don't forget to love math. And remember, you can do it. All right, I'll see you next time. Have a wonderful day.